In today's lesson, we're going to be introducing the parent functions that we're going to be working on throughout the course of Algebra 2. In this lesson, again, we're just going to look at what names we can associate with the different functions and the different pictures. So we're used to seeing those pictures and matching them up. Just a note about completing notes and checking out these videos. I do not expect you to necessarily print out the organizers that I use when I'm filling out these notes and presenting these problems. You are more than welcome to do so. I will be posting the completed version of this as well, along with the video. So you need to choose what's the best way for you to record the information. When we're working with math, definitely the best way to remember it is to write it down in some form. So if you're not printing up the organizer, do you still have a way to write down your examples, note what I go over in these videos, so you will have something to go back to, and also writing it down just helps you remember better. So let's check out our first couple parent functions. And again, these are called parent functions because these are the basic shapes of these functions that we should usually recognize when we're working with these. And we'll start being able to connect how these graphs look with different modified equations the more of these that we practice with. So our first function that we're looking at is one that you've probably seen before. This is actually our constant function. And this function specifically is actually the equation y equals 2. But in general, our constants are always going to be y equals a number, and they're always going to be a horizontal line. Now, our kind of other views that we could use for this, we can put this line anywhere we want. It could be further up, it could be down below the x-axis, but it's always going to be this horizontal line. Now, the important thing to remember is the horizontal line is the function. So you probably remember from Algebra 1 that you did probably do some graphing of vertical lines. And so just as a side note, your vertical line, it's always going to be an x equals some number, no other variables in it. But the thing about this is that it's not a function. Keep in mind, if we're defining what a function is, it has to be something that doesn't have any x repeats in it. And so if we think about the different values on our constant function, I can take or look at a whole bunch of different values. Every single one of them has a separate x value, although it does have the same y value. If we're looking at the vertical line of x equals whatever number, and we look at a number of points on there, they're all going to have the same x coordinate. And that's our measure of whether or not something's a function. If it has those x repeats, he's not a function anymore. So technically, the only one that is a function is that horizontal line. All right, let me change my color back. Okay, the second function, again, should look very familiar from Algebra 1. This is actually called our linear function. And again, we distinguish between this and the constant function because it is going to be at kind of an angle. It's going to be slanted. So this actual equation that we have, y equals x, although you're used to seeing this in the format y equals mx plus b, with your m being your slope and your b being your y-intercept. And again, we can recognize these functions as a linear function because it is, again, it's a straight line, it's slanted. It doesn't have to be slanted up to the right. So we could have a line going up to the left. The equation of this one would be y equals negative x. And again, having that negative sign in where our slope goes means that it's going to be tilted up to the left. Now, I'm going to pause on the equations here. We're going to look more at the equations of the remainder of the functions during our next video. But right now, for these other functions that might look a little new, all we're worried about right now is matching up the picture with the name. So our first function that might be new is our absolute value function. And so this is the function where you've probably already taken absolute value of a number. So absolute value of 2 would be 2, absolute value of negative 2 would also be 2. It's always that distance away from 0 on the number line. And so anything that's going to have that kind of V shape, we can consider an absolute value function. So even if it's pointed up or if it's pointed down, those are going to be your absolute value functions. Now, I didn't think about too much flipping it left to right, because if you think about that V shape, if you flip it horizontally, is it going to even change the picture? So we don't tend to look at those types of changes too often. We can't see those very apparently on the graph. Okay, our next graph is the square root function. So exactly what you're thinking of when you hear square root, like taking the square root of a number. So think about what numbers you can take the square roots of. Can you take square roots of negative numbers? So our original equation, you'll notice it doesn't have any negative values in there. But again, once we start looking at the equations, if we start playing around with those, we're going to actually be able to flip these graphs around. So that same basic shape, we could see that flipped down. We could see that flipped to the left. Or we could actually apply both of them, flip it down and flip it across. So we could do both a vertical and a horizontal reflection, and it could go that way. And by the way, every time I'm leaning down, I'm actually making notations on a tablet computer right now. So that's why I keep leaning down. My camera is up a little bit further. Alrighty, so next function, if you think about square root function, think about what that opposite operation is. Instead of taking a square root to make something smaller, to go the other direction, instead of taking the root, you are actually going to be squaring. So this kind of related function is what you might think of as a parabola, but formally it's known as a quadratic function. I'll abbreviate function. It kind of looks like a parabola, looks like a U shape, but it has a nice curve to the bottom instead of that absolute value that comes to a very abrupt V. And again, if we were to try to do any reflections on this horizontally, our shape wouldn't look all that different, but we might absolutely see the upside down quadratics happening. Alrighty, next function. Okay, so our next function is actually cubic. And this kind of goes similar to a quadratic function. It's our parabola. Do you remember what type of values you see in that kind of equation? So when you work with parabolas, you usually had x squareds or x raised to the 2 power. When you're dealing with a cubic function, your equation is actually going to look like x cubed or x to the 3rd power. And that's why we call this the cubic function. And again, we could look at different ways to move these around, but one of the other views that you might have for a cubic function, let's say we flip this vertically. So if we kind of twist it around the x-axis, we'd have a graph that looks sort of like this. That also kind of looks similar to if we reflected it over the y-axis as well. But again, don't worry about the equations just yet. We're going to look at that in our next lesson and start figuring out what those values are going to look like. Just like you can relate the quadratic with the square root, you can relate the cubic function with the cube root function. And again, you'll notice they look kind of similar. It looks like you kind of flipped things around a little bit. Again, we'll get more into the individual pieces and more into the different points a little bit later. But again, anything that looks in that vein. So think about what would it look like if we reflected it across the x-axis or reflected it across the y-axis. Across the y-axis, it would look like, instead of going up to the right, we're going to go up to the left. Instead of going down to the left, we're going to go down to the right. But again, it's going to look very similar if we flip it vertically over that x-axis. Alrighty, 2 more functions to go. Excuse me, 3 more functions to go. So our next function looks a little different. He has 2 different pieces to him. So this is what we call the rational function. I know I said I wasn't going to be going through equations on here, but I want you to think about this equation a little bit. Where have you heard the word rational before? So if you're thinking it's a type of number, you're exactly correct. So any rational numbers, again, those are actually fractions, or they can be written as fractions. So this function, again, we're going to explore this a lot more in our next couple lessons. Our rational function really looks like 1 over x, and we're going to be doing variations on that. And so the piece of this that I want to note especially is what kind of values would you have problems with if you tried to put them in that denominator of that fraction in that rational number. So the only number that you can't divide by is 0. And so if you'll notice, you have this gap in the middle of your graph, and that's because you cannot divide by 0. It does not, you get an error message when you put it on your calculator. It's just not an operation that you can do with 0. And so that's why we have that gap in there. Rational function, again, we can play around with how it might be flipped around on the graph or moved around. So even if you see something with those two portions, a lot of times we call these branches, you'll just see them in the opposite quadrants, but those are still going to be rational functions and they're still going to behave the same way. Okay, 2 more functions, and this one's probably first and foremost in your mind if I start talking about the kind of data that would actually make this. So think about what we've all been going through in the last 6 months. So with coronavirus and more people, unfortunately, contracting the virus, think about what the numbers are doing generally. And so they're not making this nice straight line. They're getting larger and larger, faster and faster and faster. And that's actually modeled by something called an exponential function. So exponential function means we keep raising things to a higher and higher and higher exponent. Again, we're going to have an entire unit that just talks about exponential functions, probably the second half of the course. So please do keep an eye out that. You'll notice I have 3 possible kind of empty graphs, because again, we can think of all the different ways that we could move this graph around. What if we flipped it down over the x-axis? So we would have a graph that looks like this. What if we flipped it over the y-axis? So flipped it left to right, we'd have a function that looks like this. And then what if we did both? So we would end up with a function that looks like this. And again, we'll explore these functions a lot more. Right now, I just want you to be noting what pictures can we associate with these names of functions. Our last function is one that I know you've never heard of before. The last one is called a logarithmic function. And again, I know that sounds very strange. It's a type of function you haven't looked at before, but take a moment to kind of compare that to how it looks like, or how it looks compared to the exponential function. And these 2 functions actually are related to each other. Again, we'll get into how they're related in a future unit. But we can look at this the same way. And again, very similar graph, similar kind of curve. We could flip that logarithm graph up over the x-axis. So that would end up looking like this. We could flip it left to right horizontally over the y-axis. So it would end up looking like this. Or we could actually do both of those and end up having something that actually looks kind of like an exponential function, but not quite. And again, we'll look into those in a lot more detail when we get to the unit that actually talks about exponential and logarithmic functions together. Alrighty, so again, go back through, check out your different kinds of functions. And again, if you want to pause the video, if you want to rewind and watch any pieces again, my goal for these videos is to keep them 20 minutes or less, so you can watch these as many times as you need to learn the information. Okay, see you next time.